This is an evaporated cooler, and this one is operated by some pumping water up here over the pads, and the water is going over the pads, dripping back down, circulating back down to the sump, providing a little bit more efficiency because the cooler water is just recirculating throughout the building, coming back. So you just have like, you know, all the cooler is draining back down to the sump, and the sump is pumping the water back up here, providing a little bit more, you know, efficiency. Water circulating, and the water is distributing from this distribution tube. Bags now. This here is pushing inside the building. So now we have, this is a motor, pulley. That's providing cooling air going inside the building. But this one, is just circulating water. They call it a swamp cooler. They just want to go in over pads, providing cooler air evaporation and water to circulate. But this is one application which you have multiple different applications here. Some of these coolers that have a water supply in the floor, and the flow prevent the water from overflowing on the roof before it's coming to the sun. Now this valve right here that allows the supply water to go over the pads, you have to be adjusting this so the water is going over the pads, because if there's too much water going over the pads, when the fan is sucking, it'll suck some of the water off the pads if the pad is too wet and there's not evaporation. So you normally adjust water supply going over the pads to a good setting where it's not into the building. There's a cooler. So where the supply air going in, it's sucking water, air inside the building. And then this one, you just have a switch that controls the high voltage to that fan. Two sections. There's another section where the air going inside the building.